Hey folks, today I would like to show you that there is a good matching between the event sourcing, Node.js, and a TypeScript. And I would like to show you why the tool that I'm currently building, Emmett, is a potential good option of doing that. So today I will show you how event sourcing works, what are the principles, and then gradually, I will show you how to build a simple but quite real-world application using Emmet. Don't worry, this webinar won't be vendor locked. I will be using Emmet, but the main goal is to show you how event-driven approach can take your application back to the future. So let's start with briefly explaining you what is event sourcing and why you should even consider using it. So the event sourcing pattern by itself is quite easy pattern. So the first thing that happens, and that's no any difference between event sourcing and traditional applications, is that you need to get the request. Normally for our application, that means getting request to web API. The only difference between the classical approach and event sourcing is that here you already should be capturing a specific user intention. For instance, withdrawing cash from ATM. Once we receive this command, then of course we need to handle it. And then the first difference comes. Because in event sourcing, the names comes from the fact that events are our source of truth, which means that they are also our state. So to make our business decision, we need to get first or read all the events that happened for our particular entity or process. So in this case, that means, for instance, all of the transactions that were recorded for our bank account. Once we did that, then there is no major difference because we still need to get the state object. I prefer to call it decision model because we will use it to evaluate our business rules. But not most often it's called the current state because it represents the state at current point in time. So we build the state by creating a default object. If you're in a C#, Java, etc., that can mean creating a object using default constructor. If you're in TypeScript, that can mean like just creating an empty object. Once we do that, then we need to apply all of the events and build step by step our representation of the current state. So for instance, if we got the incoming transfer, then we need to increase our bank account balance. If we get the transaction about the credit, then we need to decrease it. If we register online payment, then again, we need to decrease it. And after we apply all the events that were recorded for our entity or process, then we are getting a regular state, which is just a regular object. You'll see that later on because this webinar will be totally hands-on. But for now, let's assume that this is a bit unusual way to get the current state. And after you got it, then you need to use it to perform business logic, evaluate all the business rules, invariants, whatever we call it. Once we get the decision, so either we can withdraw cash from ATM because we have enough money, or that no, we cannot because we don't have any money, then we need to record an event because the outcome of our business logic is recording new fact, a new thing, a new information about what has happened in our business process. And that's an important difference because we are not overriding the state, but we are just recording new facts. So no data is lost in event sourcing. This is really critical because nowadays storage is rather cheap, which is a bit different than in past, but the information is priceless. So by recording new facts and new events, we are getting a full observability and full tracing, both from the business perspective and also from the technical one. So for many years, event stores were explained that, yeah, they are just append-only log. So we are recording new facts one after another and then just gradually creating like a long tail of facts that happen in our system. And I don't think that this is the best way to explain event sourcing and how event stores are working actually. Because for many cases and for many of them, physically, they are indeed append-only log because we are adding new events one after another. However, logically, if we look on them, then this huge append-only log, potentially huge append-only log, is actually splitted into logical things, and those things, those groupings of events, are called event streams. Event stream is the representation of our record. So event stream is built from the key or ID. So you can think about event stream as the representation of our traditional records. So a single record, a single row in the relational table, a single document in the document database should be represented as the single stream. So each bank account, each user, each fulfillment process, each invoice will have its own stream. And by that, as you see, logically, streams are just key value pairs, where key is the record ID, so entity or process ID, and the value is the sequence of events. And that's quite important to understand what guarantees we should expect from our event stores. Because if event stores are key value databases, then we should expect the same guarantees for our event store as we normally expect from key value databases. So if someone says to you that event stores are append-only log, then maybe they are, but that's a physical implementation. Logically, they are key value databases where each record is called stream, and it's just a sequence of event correlated by ID. And let's discuss how we actually can store that, because it doesn't mean that if event stores logically are key value databases, then that we cannot store them in the regular relational tables, because we can, just like we do in Martin, just like we do in Emmett, because Emmett also has the relational database. We could keep all of our events in a regular table where data is stored as a JSON-B or binary object, and the rest of the data is actually metadata, so the columns that are all the same for all of our records, so like a stream ID, event ID, event type, all of them can be modeled as a regular columns. And if you think that, yeah, like a really big events table wouldn't be that too much, well, it depends on your scale of the system. But typically for relational databases, even if you had hundreds of millions of records, then it shouldn't be a big deal if you provide an index based on the stream ID and the position in the stream. Because normally, as you saw, we are reading all the events for a specific stream and just appending new record. And that can be even more performant than the traditional usage of relational databases, because the performance issues that they have are usually related to random updates to rows in the big tables or deadlocks, etc. Here, you don't have that because you have a simple access pattern. You are either reading all events for the specific stream or just appending a new event. And of course, it's not like we need to use a different database underneath, like a relational database, Mongo, or any other storage. We can also use solutions like Event Store DB, or currently rebranding into Current DB, or Axon server, and all of them are just keeping data as any other traditional database, so as files on a disk, so using binary format. So there are plenty of options that you can use to store your events, and that's also the big benefit of using Emmet, as you see, because in Emmet, you currently have the following storages: PostgreSQL, SQLite, MongoDB, CurrentDB. So you can choose and align that to your system requirements. So why didn't I mention Kafka? Because Kafka is actually not an event store. It's not tool built for that, because Kafka doesn't have the basic guarantees that you would expect from the key value store. And that's why is it the critical distinction, because Kafka is indeed append only log, but it doesn't have capabilities to easily just read the events from a specific stream, because it can only subscribe to the specific topic or partition, which means that you would need to read all the messages from the partition to just, if you just require a subset of it. It doesn't provide the capabilities like real transactions, like optimistic concurrency. And that's fine, because it's not a tool that is made for durable storage of the data. It's a tool that is meant to facilitate moving and integrating services as fast as you can. And I think that's enough of the intro, because I think that 10 minutes is already too long to explain event sourcing. But of course, I'm joking a bit, because we will be discussing event sourcing, but on a real world example. So I'm showing that I would like to show you the code. But before I do that, let me start with explaining you the specific business use case that we will be using. And don't worry, we won't use the bank account. We will use something a bit different. So let's say that we would like to build a system that is managing and taking the responsibility of the financial aspects of the guest stay in the hotel. And actually, that's a system that I was building, and that when I was starting my first event sourcing journey. So that will be a bit also bring some memories to me. So the first thing that needs to happen if we are thinking about the guest day is that we need to check in, because from now on, we are starting the stay, we will be managing it, and as a result, of course, we will get the new invoice, because if we don't have invoice, we don't have money, and if we don't have money, then why wouldn't it be building such system? So the first thing is that the guest is coming to the clerk, to the desk, and is saying that I would like to check in. So then the next step that needs to happen is that clerk, so this smiling guy, need to ask a few questions. So most importantly, they need to check whether the guest hasn't already checked out, or isn't the guest already checked in, or actually is there any reservation that was made for the specific guest. And let's say that everything went well, so we can successfully check in our great guest. So that means that we can, in event sourcing, record a specific event, which is the guest checked in. And after we do that, then our stay is not longer not existing, but it's a checked in. and we can take the full benefit of being in the hotel. So of course we can do and drink some fancy drinks or eat some dinner or benefit from the spa that is in the specific hotel. And of course, if someone would like to register the charge, then we can already pay with our credit card or cash, or we can ask the waiter or the waitress to record and register our charge for our hotel for our room number. So then, of course, the bartender or the spa assistant need to check whether we are already check-in, whether we are actually a guest in the hotel, and so on and so forth. And if everything went well, then we can say, sure, let's register the charge and have fun. Unfortunately, we can have fun for a long time, but this fun at some point can end, which means that we need to pay our debt. So just like Lannisters, they always pay their debts. And as again, we need to check the similar things. So if we come to the hotel and we would like to say that, yeah, we would like to pay for our stay, and then it appears that we actually mistaken our hotel or we already checked out, and or there is some other issue, then of course we cannot register our payment. But normally, if everything went well, then we get another event. And after we settled everything and our guest state has finished, then we can actually check out, because there is a rule in the financial module of hospitality industry that we can only check out guests if the balance is settled. The balance is settled means that the difference between the sum of our charges is equal to zero if we minus all the payments that were registered. So even if we lose our wallet, then that's still doable, because remember, accounting is not precisely the reality. So if we have the rule that we cannot uh, check out guests if they are not already checked out and the guests lose the wallet, etc., and cannot pay, then we can always register the payment, but with the delay payment date. So then, from the accounting perspective, everything can go well. But here, let's model also this scenario where we weren't able to check out guests and we asked them to maybe do some stuff like, maybe could you go to the ATM machine and try to withdraw money and pay us? So let's try to model here also the negative scenario. So here the guest can either check out, and then after we did that, then we are registering guest checked out event, or if we failed for some reason, then we are registering also this information. Because for our business use case, that's quite often the case that uh, registering negative scenario can bring a new insights to our business people. And but let's say that we successfully checked out guests, then of course the stay is finished. We can probably do some other operation like printing invoice or doing some other summaries. But you know, today let's focus on how to implement such a basic flow. So to sum up, the guest can check in. After they did, then they can start to use the facilities in the hotel, which means that they can register uh, charges for the spa, for the night stay, for any service that our hotel provide. At the end, they need to pay for everything, and they need, after they do that and they settled the balance, so the balance is zero, they can check out and finish their stay. So this is our uh, humble business use case, and let's try to have a look, as I promised, in the code, how we could actually model that. Because for me, one of the biggest benefits of using event sourcing is that it streamlines our understanding between our business people and our technical people, so like technical people like me. So let's say that we will be modeling the guest stay accounts. And let's start to show you how the business logic could look like. So let's create a simple business logic file and try and start with defining our guest stay. So guest stay command are all of the requests that can be made in our system, in our guest stay account. So as you saw in our domain model, then those blue sticky notes in the event storming notation means represent all the intention to do something. So as you see, all of them are like an input. So they are on the left side of our process. So our input that can trigger our business logic. And as you see, we are naming them in the business terms. So let's try to define how they would look like. So the first one is the check-in. And we are saying that for that, we need the guest ID and the room ID. And if you have good eyes, then you already noticed that there is a specific type command. So where can we find it? And actually, this is the first place that you will see the Emmett in practice. So command is actually just a simple DTO. It gathers the data because commands, besides representing the business intentions, are just the regular messages, which are represented by type, data, and potentially metadata. And command is just a type that just unifies the processing and the definition to make all of our commands having a similar structure, which in TypeScript is quite important to be able to benefit from the structural typing that TypeScript gives. But of course, you don't have to use it. This is more just to reduce the boilerplate and help you to quickly start with using using event sourcing and just focusing on modeling our business domain. So as you see, while talking, I brought also the definition of the other commands. So if we are recording charge, then obviously we need the charge ID, the guest account ID, which will be created after we check in our guest, and the amount. Similarly, record payment will have the same payload beside a different ID and a different type. Because even though those two messages look similar, they represent a different business intention, which can be quite important. And after we did that, then boom, we already have our definition of what can happen and what business logic can be triggered in our guest stay account. So the next step would be to define our decision model. So define how our guest stay account can look like. And the trick that I would suggest you, if you would like to model your decision model, then go to those yellow sticky notes. They represent business rules. And to model efficiently in event sourcing, but not only, the business logic and decision model is to only put in it only this information that is required to validate those business rules. So as you see from our short business modeling, we had the three states. So either the state is not existing, or it's checked in, or it's checked out. And as we are using TypeScript, then why not to use the union types and tell precisely that our guest state, it is like that. So it's either not existing, or checked in, or checked out. And the not existing state could be represented as that. So we are just saying, fine, the status is not existing. There is no other data because it doesn't exist. So then we have the checked in state, and we say that status now is checked in, and we have our balance. Because if we go back to our processing, then see our business rules are only checking the status, and the balance is settled. So if it's equal to 0, technically we could use the Boolean flag here, is it settled or not, but we need to have actually the number, because we will be increasing or decreasing it based on the information that was stored in the event. So each financial transaction will update the balance. And the final state is that our guest state was checked out. And we need to do one more thing and tell that our initial state is not existing. And you might already notice that this looks similar to the state machine, because we just define all of the possible states, we define how they look like, and the initial state. And indeed, event sourcing works best if we are trying to model something that is close to the state machine. It doesn't have to be precisely state machine, but something where there is at least multi-step process, because then you can get the full power of using event sourcing. It doesn't have to be anything extremely complicated. As you see, our current business use case, it's quite simple, but still it can bring valuable possibilities after we have our events. And as I mentioned, event sourcing comes from the fact that our events are the source of truth, and we are capturing all the information of what has happened. Then let's finally define our events. So we will use a similar pattern as we use here for our guest day account or for our commands. So we will define that as an outcome of our business logic, we can get the following events. So guest checked in, charge recorded, payment recorded, guest checked out, and guest checkout failed. And as I mentioned, the blue sticky notes, so commands, are the inputs of our business logic, and our events, as you see, they are outcome, so outputs of our business logic. And if we are discussing with the business people, and if we are ending up with a domain model expressed by events, then it's really, really simple and valuable to do it, because then we can also express that in code. And as you see, we are even in code talking with the using the business terms, which can streamline and make easier discussion with our business. So, as you can guess, as we had the command type, then Emmet also brings you the event type. An event type is similar to command because it's also a message. It also has type, data, and metadata, but it represents something that has happened. So what has been seen cannot be unseen. And command can be rejected because it's an intention. And our business rule can say that, no, you cannot perform this operation. But with events, they are just recorded. The business logic was validated before producing them or creating them. So we don't need we cannot say that, no, it didn't happen. Of course, we can try to ignore that fact, but it was already recorded if we are using event sourcing, and we should treat them as something that is already happened. So events, normally they will go like one-to-one in almost majority of cases. But they will have some additional information that are coming from our business logic processing. So for instance, we might have some additional dates when it was recorded, when the checkout was made, and so on and so forth. We can have additional event representing the failure. So for instance, that guest checkout failed with the reason that it failed because the guest wasn't check-in or the balance wasn't settled. We can have also some additional information, some metadata. But let's keep things simple and focus on the domain and how we can run our business logic and write our code. So we already have our API, so our commands. We have our events, so our state, and our decision model that we will use to verify our business logic. So let's try to code the business logic. And let's put it into the business logic file. So here, what we are doing is that we have the function that takes two objects. The first one is the command, the second one is the state, and we are expecting either an event or an empty array. An empty array with the Emmet conventions means that nothing has happened. If we are trying to check in guest that was already checked in, then we could, of course, throw an error like here, that we cannot check in because it was already checked out. But we can also silently succeed. This is quite useful for many cases because, let's say, we accidentally get the same request twice because of the retries or some timeout. And here we are saying, fine, we already checked in the guest, so let's not do anything. Let's not record any new fact. And if we see that this case is more like a showstopper, then let's just throw an error. You could technically also return here a failure event or maybe a result. In Emmet, normally I suggest to throw exception because that's something that should not happen, at least for the regular command processing. However, it's up to you because Emmet, as you see, there are no major types here and no classes, no specific structure besides the convention that you are taking the same set of inputs, so command and the state, And as a result, you are getting either a single event or an empty array of events or multiple events, so an array of events. So my idea behind Emmet is to just allow you to write TypeScript code. And my friend Mario told about Emmet that it's just enough ceremony. So I'm focusing on the TypeScript, on the specific structure, so just like TypeScript suggests, but nothing more. And let's add one more function. So this will be our guestStay account ID function because it will be built from three information actually. So our guestStay ID will be represented by the guest ID, room ID, and the date at which the guest was checked in. So by that, we are also getting the uniqueness guarantee because in any event store, you have the guarantee that the same, you cannot have two streams, so two records with the same ID. Again, that's something that you normally should expect from your databases. So the code is simple as that. You are just getting the intention, the current state, and you are performing the business logic. Nothing fancy and nothing more to elaborate. Let's have a look on how our recording charge will look like. So again, pattern is the same. We are getting command, so record charge. We are getting the state, and as a result, we are getting event, or we could also get more than one. And what I did here is that I also added some additional function to make this business logic a bit more descriptive, but essentially I'm just doing those checks that are described here. So is guest already checked out or is guest already checked in? See, those are precisely those checks. And record payment, not surprisingly, will look the same as payment, besides the fact that we are recording different event because this is a different business information. And my suggestion and the recommendation is to not try to be too smart and not focus on the don't repeat yourself here, because maybe at the moment you are starting with your business logic, this code may look the same. It's tempting to unify those events into the same type or the function into the same function. I discourage you to do it because those functions are still pretty small. They are focused, and as your requirements will grow, and usually they grow, then it will be easier to put them into the specific places. Plus, the events should be really focused on the business logic, because after we store it, the big benefit is that we can build projections, for instance, only view about the payments or only view about charges, or maybe we can trigger some follow-up workflows only based on the specific business event type. So don't be too smart. Don't try to uh, optimize for the code size. Focus on keeping the business concepts together. So keeping and slicing based on the business operation, and then you will be, I guarantee you, the most efficient and effective with using the um, event sourcing. So now checkout is a bit different, a bit more complicated because those were extremely simple. So checkout, what am I doing here is that firstly, I'm checking whether the status is different than checked in, and then I'm recording and returning an event that gets checkout failed, because see, we are simulating here that maybe business said that this is an important thing to capture, that something has failed, because that's an important information that they would like to then be able to troubleshoot. So then we are giving a specific reason. And after that, we know that guest is already checked in, so we can check whether the balance is equal to 0. If it is, then we are returning the successful event. If it's not, then we are recording an event with the information that balance was not settled and the guest checkout failed. So see, there are plenty of options how you can code, but the most importantly that we got a really simple and straightforward code. And really, if you focus on making your decision model thin and without any fluff related um, to the um, like a read information, then the business logic in event sourcing normally looks like that, because you don't need to repeat all the information that you place in the event unless you require them to evaluate business rules. So the final step that I would like to do here is that I would like to expose the final function that could be an entry point and a grouping for our business logic. So it's just a simple optimization where we are saying that, hey, this function takes any of the guest state commands, so check in, record charge, recon payment, checkout, and it's returning an guest state account event or an array of guest state account events. And then based on the command type, and see that's why we put this type here, we are running a specific business logic. And because TypeScript is giving us the full proper union type checks, then when we add new command, then this condition will fail and we will get the compiler warning that we should also include this command here. So again, we just coded the guest state API, all the commands, all the events, even all the business logic. And the one thing that we didn't is how to actually get the guest state account state from all of those events. So let's do that. Let me show you how you could do it with the in the event sourcing. So normally, as I mentioned you, let me go back maybe to those slides. So see, the first thing that we do is that we are reading all events. And we will get those events here. See, this is the list of the guest stay account events. And as a result, we would like to get the flattened representation, so our decision model. And we do that by applying one after another all of those events to the state. And we are starting from the initial empty state object. And that's why we also needed to have this initial state, which is our entry point. And then one after another, in the order they were recorded, we can iterate through all the events that we got from our event store, and then we can evolve our state. So we can take the current state, use the event, apply it, and evolve into the new state. And if we do that for all the events, then we would get the final state. And as you see, the TypeScript is telling me that we should define evolve function, and we will do that in a moment. So if you'd like to simplify that, and if you are the, let's say, TypeScript or a JavaScript hero, then you could also even do it simpler. So use the reduce function. So we are saying that we are starting from this state, and one by one, we will be evolving our state. So let's try to define our evolve function then. So evolve function takes the state, the event, and it returns a new state. So new state with the state from the previous one and the information from events. So let's try to switch by the event type, and let's try to define how we will be evolving our state. So if the state was not existing and we get the guest checked in event, then we should produce the new state that has checked in status and the balance equal to 0. So precisely what we had here. And if we have our charge recorded, then not surprisingly, we need to just decrease the previous balance by the amount from the event. And if the payment was recorded, then it's a similar but the other way around, so we are increasing the balance. And what if the guest was checked out? Then we are just marking our status as checked out and calling it a day. And what if our guest checkout failed? And actually, we don't need to do anything because that's just an information for our business. So we have this observability. Maybe we can trigger some notification or some other business workflow based on that, but it's not impacting our decision model because we just recorded it. So see, we just define the evolve function that will tell us that how to build the state and how to evolve it if we get all of those events from our event store. Simple as that. So, okay. So one thing that I'm hearing from time to time is that many people tell us that event sourcing is hard to test. Let's try to evaluate this common myth. So one thing, because I'm listening, I'm hearing what people are saying, I understand where is it coming from, because event sourcing is a bit different pattern. It's you not only need to learn new stuff, but you need to also unlearn your regular practices. So it's a mind exercise and it takes time, and I feel that. And one of the issues, besides telling that event stores are up and only log on teaching event sourcing and tooling, was that we were not giving people the capabilities to, for instance, test if what they wrote will actually work. And that's one of the reasons why in Emmet you can use your built-in test specification and write your test in the following form. So, so you can, for instance, start with coding your test in the following way. So you can say that given non-existing account, which means that empty array, when you run your command, so when you are saying that you'd like to check in, then you are expecting that you will get the following event or events as a result. You can also verify that, for instance, for not existing account, you cannot record any charge, and then you expect to have the following error. Or you can also check same for payment and for the checkout. And you can go even further. So, um, ah, see, I'm not great in copying and pasting. So let's do it this way. Yeah. As you see, I have uh, the the following tests that are running automatically, and they are marked as green. So seems that I did something well here. So again, it's a simple behavior-driven pattern. Given the following set of events, when I do the following command, then I'm expecting to get either an event, array of events, or an error. And the specification is just using the decide function, evolve function, and the initial state that we defined. Internally, it will take the array of events that we defined. It will run a similar code for building the state internally, and then once you provide the command, then it will use the state that it built to evaluate with this decide function whether what is the outcome of our business logic. So if you look on those tests, then they are actually also looking like mm, documentation, because you can write it in a given when then format. So what if you'd like to have the account that has more than one event? Fine. You can say, let's say I have settled account, which means that the stream in our event store, and the stream again logically is a record representing the specific guest stay that has the following set of events as value, and it's represented here. So it's an array of events that the guest was checked in, the charge was recorded, and the payment was made. So once I have such settled account, and if I try to record charge, then of course I can do it. If I try to record payment, sure, why not? And if I do the checkout, then I also can do that, which is pretty neat. And if we can go much further with those tests. And if we can even add more tests, like when when guest is checked out. And again, we can look at the specification and see what is the specific state of our stream that we are validating. And then again, if we try to check in checked out account, then we will get the error. And the same for all the other operation, maybe besides the checking out, because then we are safely just returning empty array, which means no operation was made. I think that these testing capabilities are pretty neat and can not only streamline your understanding, but also make you trust more with the with your code and with your business logic that you just wrote. And you can even verify whether what you wrote will actually work without spinning up the real application and real integration test and using any uh, event store. But well, um, I promise you that we will build the real application and that we will use the real event store. So let's try to do it. Let's try to define our API. And I'm in a team that if you are using Node.js and TypeScript, then you don't need a lot of boilerplate, that you don't need a lot of stuff that frameworks that were built by copying things from ASP.NET or Spring Boot are bringing to this environment. I like Node.js and TypeScript the most because it's lightweight, and I would like to keep it lightweight as it is. So I will use the Express.js to build the API, and also some helpers. Again, they are not replacing Express.js, they are just adding some additional capabilities to make working with the all the Express.js API a bit smoother. So let's try to define our API. And I like to be explicit about the dependencies that I have in my code. So I don't want to hide those dependencies. I like when I look on the application, then I would like to understand what does it need to be run. So in this case, the guest stay account API requires event store, obviously, because we are doing event sourcing. PongoDB, which is my special flavor on top of Postgres, another uh, tool that I might record some follow-up webinar. That is just using Postgres and also soon SQLite as a document database. But you can treat it as this is my read model storage. You could use Drizzle or RM or whatever you prefer. And I also have some additional calls like calling additional module to check whether the guest stay exists, so whether the reservation was made. I have some non-deterministic code like generate ID, get current time, etc. So all the code that is random or calling some external APIs. And but you can compose it however you want. It's up to you. So as we are building API, then I like to define clearly what I expect from the API. And it's not like that event sourcing requires you to build API in some specific way. We will use Express.js, we will build REST API, but this REST API will be focused on the specific tasks that are performed. So they are representing some business intention, because without that, we wouldn't be able to record the business meaningful events. But besides that, as you see, they are just requests. They have some body. They have some root parameters, um, and that's all, right? So nothing fancy. So let's have a look how checking in our guest API would look like. So the API would look as follows. So here we are saying that that we have the API with the following URL because it's made for the specific guest and for the specific room. It's a regular post. So see, I'm using REST API. I'm just doing some basic validation. I'm getting the current time that I will use for my business logic. And to be able to do it, then if we are doing event sourcing, and especially event sourcing with Emmet, then see, I'm translating those parameters that I get from the API request, and I'm building the command, because then I know that once I build the command, then it's already validated for the semantic meaning. So if it's really a string, if is it not empty, is it a number, whatever. I'm also passing the now into metadata, because then I can use that in my business logic code and making non-deterministic date generation deterministic. Because see, I will just use the the date information from my command. And then I can fully ensure, as you saw in the business logic, that if I provide this in command, then I can also test whether I got the expected date. So the common issue with business logic code that is generating new date, etc., in its own. So nevertheless, we are validating the API request, we are building the command, and then we are saying, I would like to run and handle this command using this event store. This is the ID of my stream, so my record, and this is the business logic that I will be running. And if you're wondering, what is it? Actually, the command handler, the command handler is a function that it orchestrates and encapsulates in our event sourcing app. So essentially what you saw on those slides. Firstly, it reads the events from the stream of this specific ID. Then it's using the evolve function that we provided to build the current state. And after we did that, then it's passing it to this handler. And then we can run our business logic and return events, which will be again stored to the stream of the following ID in the specific event store. So we will do exactly what was showed here. Again, we run our business logic, we created new event, we store it back to the same stream. Simple as that. So, of course, this is the code that some people don't want to have. Some people would like to just, I would like to just spin up the command. But in Emmet, I'm not optimizing for those cases where, like a code size. I think that this function is still small enough, but it precisely tells you, if you look on it, what is it happening. And that is a big power, because then you could even take this function and put it into the different place, scale it differently, and you clearly see all the dependency, everything that is happening, and it's still small. So for instance, this is one of the additional things that I'm added to Emmet, like returning the created status instead of calling next in Express.js. So it's not like I'm not trying to cut the I'm trying to tell you that you need to do the boilerplate, but I'm just saying that you should have just enough ceremony, as Mario Bittencourt coined it. So be explicit on the stuff that should be explicit, and don't need to think about the boring code that you wouldn't need to think of. So again, see, I generated the ID, I generated the date here and passed to the command. Then my business logic is predictable, and I can test it with this neatly, I think, made syntax. And if I have external dependency, then I can also call them here. So for instance, I could ensure that the guest state already exists, and I would just call this specific function, does guest state exists. Um, uh, uh, uh. And if it doesn't, then just say, no, the operation is forbidden. So I'm treating the API as the application layer. However, if you'd like to, you can put more layers, you can group it. It's up to you to prefer. I won't tell you how to live. I'm just giving you the tool to have the minimum set of the the minimum set of boilerplate. So recording charge will look similarly. So we need to parse the guest account from params. We need to build our commands, and then we are running our command handler. If we'd like to record payment, then recording payment is similar thing, because we are again building the commands from the validated data from our request. We are running command and returning the status, the HTTP status. If we are doing checkout, then it's the same repeatable pattern. It's boring in a way that it should be boring. So it doesn't require you to write a lot of fancy code, but it tells you and helps you to self-document and to evolve your your application in a predictable way. And if we have a look on our um, mm, on our application, let me just define a dummy. Yeah. Okay. Let's see. Copilot. Okay. See. Well, that was quick. Um, yeah. Let's do the partial here. Sounds good. All works. All compiles now, I think. Sure. So see, we just created a real API, the real world API, using requests, using Emmet, and just building and focusing on the business logic and the business tasks and business processes. And the thing that is still left, and what's even TypeScript compiler or actually as linter is telling me, that we have the following request that is not yet being used. And this request is to get guest state account details. And we discussed how to build the business logic, how to run it, how to store the events, how to read the events. However, in the typical application, you also need to read the summaries, like a summary with the details of the guest account, maybe a list of guest accounts in a admin view. So for that, it wouldn't be extremely performant and the best way if you try to read all events from all those accounts and then in memory build its representation. Because for the business logic, it's more than enough to do it because those events are rather granular. But if you have the screen when you would like to read 100 guest day accounts and then each of them will have like 10 events, then you would need to read thousands of events. That wouldn't be like a huge, but it still would impact the performance. And it's not like that in event sourcing, you will need to have like half-assed performance. You shouldn't have the trade-offs of that. So for that, from events, you can also build your read models. So let's try to show you how you could do it using Emmet. We would like to use it in a way that, again, we are parsing our parameters and then we are running the query that should return us a specific data. So let's try to define it. How to return the guest stay details. Let me import a few stuff. And we could also try to build our read model using union types. You don't have to, but it can be useful. So we can say that either the guest state details is not existing, so we haven't got any record, or it's checked in. Maybe we would like to only show the checked in and checked out records. Yeah, so probably I should name it like existing or whatever. So it can be checked in or checked out. And as you see, it's different from our decision model. So our decision model is purely focused on running the business logic. So it only has status and the balance. But if you would like to display that, then we would like to show all of the information. So guest ID, room ID, balance, maybe also transaction counts, maybe some list of transaction, check-in date, check-out date. So everything that we had in our events, but showing it as the flattened view, showing the current state. So to be able to build such read model, we also need to build it from our events. And again, we could define the evolve function. So using already known pattern. So it is like a guest state details. And for each event that will be recorded from the guest account, we will be using this event to build also the representation in of the our read model. So if it gets checked in, then we fill this information from events. And here we are providing some default values like balance equals 0, transaction counts is 0, empty array of transaction, and so on and so forth. If we are getting the charge recorded, then we are decreasing the amount count, incrementing transaction count, appending information about the charge. Similarly, for the payment, we are incrementing, then adding 1 to transaction count and extending the array. If we are checking out, then we are just changing the status and adding the checkout at information. And yeah, if checkout failed, then we are not actually doing anything again, because it's just an information. So if you're using Emmet and if you're using Pongo, so underneath you have Postgres or SQLite, then you can define the following Pongo single stream projection. We are saying that we would like to store that in the collection, the following name, which will be represented as the table in the Postgres. We will be handling the following set of events using the evolve function and the initial state defined like that. And then if we have such a read model made, then we can also define the guest state details function, which will, let me add the import to Pongo. Which will query our Pongo database. So Postgres uses as a document database for the specific table and with the specific filter. So just by ID. But of course, we can do more than that. We could filter, if we'd like to, we could return list. We can do some transformation, whatever we prefer. So it's up to you to decide. And this projection can be either updated synchronously in the same transaction if you're using Postgres or SQLite, or it can be appended in an async projection if you're using any of those databases, or you are using asynchronous projections in them, or event store DB or current DB. Then you need to register it asynchronously. So it's not like if you're using event sourcing, then you need to have eventual consistency, because you can open the transaction at the moment you are running the application logic. So handle method will actually open transaction around it if you're using Postgres. Then when you are appending events, then you can run and check whether uh, whether you have the projection registered that can handle the following event. So that's why we provide this function here. And if we have, then update read model in the same transaction, commit it, and call it a day. And then we are getting immediately consistent read models after we appended event. I'm not saying that this is always the best idea. Sometimes async projections can be much better and more performant, but for the simple cases, why not? So let me show you how to orchestrate all of that. So if we have this, uh, if we are using Postgres implementation of Emmet, then you can use just get PostgreSQL event store. You can also use the get in-memory event store, or event store DB, or inline or SQLite. You can, or MongoDB. You have plenty of options in Emmet. But here we are using the most popular option for our users, so PostgreSQL. And as you see, we are passing the connection string, and we are registering this projection as an inline. So inline means that it will be handled in the same transaction as appended events. And we are also defining our read store, so our Pongo client, to be able to query it. And let's just define also those dummy methods, like checking whether guest stay exists. And then we are registering our API and starting our application. Okay. What's wrong? Yeah, now it works fine. Event store, read store. Yep. So see, what we are actually doing here is that we are defining all of our dependency, all of our starting point, both Emmet event store and Pongo will define the tables automatically for you. You don't need to run any migration, at least for the basic setup. For production, you may consider to do it, but you don't have to. So after that, when you do it, then you need to pass them to our guest account API that we just defined with all those dependencies to make them real database, real queries. Normally, of course, you wouldn't have such dummy dependencies, but some orchestration with other modules. And then we are just starting the regular Express.js application, see, and we are starting the API. And if you do it, then the big benefit of using the start API from Emmet is that you will have all the middlewares defined. So for handling JSON, for returning the common errors with the problem details. So for instance, if you are using Emmet errors, you don't have to, but if you're using them, then for instance, illegal state error will be translated to 403. And there are also other predefined errors that you can use, but you don't have to. It's just an option. So it gives you some additional basic setup that you don't need to think about. But besides that, it's a good year-older Express.js that we love. So to sum up what we have right now, we started by defining our business logic API. So all the commands. And so those blue sticky notes representing the business intention. Then we defined our decision model. So decision model represents the state that that we will be running our validation. So from our business modeling, it appeared that it can be either not existing, checked in, or checked out. And based on the business rules, so those yellow sticky notes, we define what data does it need. And then we also defined all the events that that can be recorded in our system. We defined how to build a state from them, and we also defined the business logic. So simple function that always have the same structure. So command, state, and event or events, or throwing exception. And after that, we build the API, which is just a regular REST API written with Express. However, it's again still focused on specific operations. If we'd like to, we can take those definitions into separate files, calling the full vertical slices, but it's up to you how to structure the code. Here, it's enough simple to keep it in one place. But if you'd like to, then you can take the specific root, even the specific business logic, and maybe orchestrate and handle each file representing a different operation. So is it always like that you need to start from commands and then business rules and then events? Typically, your modeling is not happening like that. In event storming, we are starting from events, but I did it intentionally to show you that you don't have to you change the way how you are defining your application. And traditionally, most of the time we are starting from operation that can happen in our system, and then we are thinking about the outcome. However, of course, if we are doing event sourcing and event-driven application, then it's always good to put our events in the first place. So that's what we did eventually, because we were able to build not only the business logic, but also the read model. So read model that is build an interpretation of the specific business process represented by the outcomes, so by the events. So Emmett can do much more. It can even help you to write integration tests, end-to-end tests in a similar fashion as I show you for the regular business logic. It can also have the consumers and processors that are handling and your events interactions. So you can start consumer for the event store, or later on in the messaging tool, build and correlate and integrate your business workflows using them. That's possible. However, that's a topic on its own. So I will cover that in a follow-up webinar. But for now, see, we built a simple application. We even tested it. It has right side. It has read models. looks good to me. I'm interested how that looks to you. So, because in this webinar, I wanted to show you that event sourcing is not that scary, that you can get strong consistency. You don't need to change all of your flows and all of the ways how you were interacting with your applications and how you were designing it. But if you're using event sourcing, then you are actually getting applications that are more focused on the business logic, and that can help you to document uh, easier document um, uh, your um, your way how you are um, expressing your business logic in the code. So that can look quite similar to potentially hexagonal architecture, because we can represent our business logic as the centerpiece, then wrap it with the application logic or vertical slices, and then, depending on our need, connecting the external data, different way of handling our endpoints, and also different databases. And all of that, by default, you are getting also from Emmet, because it's built to support various use cases and various needs of today's applications. So I hope that you enjoy it. If you have any questions, feel free to ask on our Discord channel. And yeah, I hope that you enjoy it. You learn how to build a simple event sourcing application, how Emmet can help you in that. But all of that I show you is also applicable to any other um, uh, coding environment, not only TypeScript and Node.js. There are also other tools like Eventus, Marten, Axon, and so on and so forth that can help you to streamline building event-driven applications. But hey, just try it, play with it, check our docs, try to replicate what I just did during this webinar. And yeah, thank you. Let's take your applications, event-driven applications, back to the future. I hope that you enjoy it. I hope that it helped you. And yeah, till the next time.